Napoleon, like anyone can even know that.
Hi friends, welcome. So as promised in the previous video, today we're going to continue doing the hack the box machine Jeeves, but as opposed to the previous time where we used Metasploits to perform our juicy potato attack, today we'll be using a more manual approach.
Would you like some jeeves?
Even though we are going to do this today, we are going to do our Jeeves walkthrough with the manual juicy potato attack. I think today's lesson actually became about much more.
Give me some more.
That's because while preparing this lesson myself, I encountered a pretty big problem, which was every single time I copied a MSA Venom generated payload over to the victim system, some form of endpoint detection, probably Defender, immediately picked it up, blocked it from running and deleted it. But as is often the case in hacking and in life in general, whenever we encounter some problem, it can present an opportunity. And so because our standard off-the-shelf payload is detected each time, it requires us to get a little bit crafty. And so without giving away too much, what we're basically going to do is we're going to repackage netcat with a simple little C script and use that as our payload.
Did he say C script?
Yes, I know C is very scary. I find it scary too. Please rest assured. The C script we're going to learn how to create today is literally the most elementary C script you can do. It is on par with a Hello World C script, while at the same time it is an incredibly useful script because you can repurpose it to directly interact with the Windows command line interpreter, i.e. directly execute commands in Windows. And so to wrap this intro up, I want to say I think this is a great course if you're a beginner moving towards intermediate, meaning you know how to generate kind of the standard off-the-shelf payloads by running, your MSA Venom command. But now you need to start really evolving that game because, of course, if anybody has any decent endpoint detection running on their system, you can't use those payloads. And so think of today as the first lesson in how you can start thinking about customizing your payloads in order to avoid detection. But in any case, methinks that is for sure enough with all this flippin' dilly-dallying, and so let's get to it. Right, so just before we get going, just one quick thing. Now obviously, as I just mentioned in the introduction, I already showed how to get a foothold on Jeeves, this machine, in the previous video. Now this being the case, I'm not going to repeat it here, so if you wanted to know how to get on the box, please go watch that video first, link right at the top of the description. But if you don't really want to, in all honesty, that's totally fine, because you could fully follow along what we're doing today and still derive all the value without actually knowing how we got on the box. Okay, so let's do this. And so as you can see here, we're on our own machine obviously, but we already have a shell on the target machine. We had our netcat listener, we ran the groovy reverse TCP script from the Jenkins interface, which called back, and now we are established as a lower level user on the target machine. So if I run who am I, we can just be reminded that we're the username Kosuke, which is a shout out to the original creator of Jenkins, right? And then if we run who am I priv, here we can see that we have impersonate privileges set. So just as a quick reminder, it is this exact privilege, the impersonate privilege, that we need to have enabled in order to be able to do potato attacks, juicy potato attacks, rotten potato attacks, etc. Now I want to be very clear, if this is enabled, it doesn't mean de facto these attacks will work. However, having them enabled is a prerequisite for them to work at all. So whenever you're on a box and you run who am I priv, or you run get UID from your interpreter session or whatever, and you see that this privilege is enabled, you now know that there is the possibility for some form of a potato attack. Right, so I'm going to hit Ctrl-Shift-T, just so that we have another tab that's basically on our own system. And the first thing I'm going to do, just a little bit of housekeeping, is I'm going to make a directory called potato, and I'm going to cd into potato. And the reason for this simply being is I want to kind of gather and keep all our files neatly together here, just for the sake of simplicity. And so now the very first thing we want to do, since this is a manual juicy potato attack and we're not going to be relying on frameworks like Metasploit to mediate the attack for us kind of like at the back end, is we need to go actually download the juicy potato binary. So I'll go to my browser, and so here in the browser you can simply search for juicy potato GitHub. And obviously if you misspell it like I did, it don't matter. And just so you know, this is the correct page, the OHPE. So feel free to visit this page and you can go through it, and it's going to go through the actual technicalities of the attack in a little bit more depth than I'm going to offer here, just in case you were interested. Okay, so I just wanted to show you this, but we'll just be downloading the binary directly from the release page in our terminal, so let's head back there. And so here I'll simply paste the command, and you can see we're invoking wget, which is of course a command line application that allows us to download files directly from the internet. And you can see that's followed simply by the URL and the juicypotato.exe binary. And since we want the file in this folder, in our potato folder, we don't have to specify anything else. So I'll just hit enter. And by the way, I'll post the link to this binary exactly as it is here, right at the top of the description. So a clear screen, and I'm just going to take a quick minute just to explain something. And perhaps it sounds like splitting hairs over semantics, but this is actually crucial to understand how this attack works, and specifically related to one of the limitations. So the first thing we need to understand is that a juicy potato by itself, if we run it, it's not really going to do anything. Meaning it's not juicy potato that's going to elevate our privileges or give us a new shell as system. Really, all juicy potato will do is, if the conditions are right, it will allow us to spawn a new process as system. Now obviously therein lies the opportunity, right? And then a second, more nuanced point is, as I just said, juicy potato allows us to spawn a new process. Juicy potato does not allow us to run a command. And there's a critical difference, because when we run a command, we are able to provide arguments at the command line. For example, which IP to use, which port to use, etc. If we're only allowed to spawn a process, in effect run a binary or run an executable, if that's all we're able to do, it means we're not able to provide arguments at the command line. It means we need some other self-contained program that we can ultimately just invoke using juicy potato. So just keep that in mind, because this distinction between being able to spawn a process or execute a command is going to be crucial to your understanding of how to ultimately get a system shell on this box. Okay, so as I just said, we need a self-contained package, and obviously as an attacker, what we want is something that when executed will basically call back to a listener on our system. And that's very easy, right? We already have a great tool for that, and that tool of course is MSA Venom, because MSA Venom allows us to generate a payload if we wanted to in an exe format, and when that is run, it's going to do exactly that. It's going to call back to a listener on our system. Still in the potato folder, I'm going to drop the command, and you can see that we're simply invoking MSA Venom. We're specifying our payload. Two things to take note of here is that this is actually the 64-bit, since we're not specifying the 32-bit x86. And another thing is, this is not a meterpreter payload, it's not for meterpreter shell. This is shell reverse TCP, basically indicates that we're going to be handling the listening with something like netcat. Of course, our L host is our IP. Our port is 3333, kind of random in this case. Maybe better to use a more realistic port we're assured to be able to call out to. Be aware of that. For more difficult machines, that would almost always be the case that you should do that. But for now, this will work. We specify the file format. In this case, I want an exe file. And then we just give it some name, any name. Obviously, in this case, I'm naming it
What's taters?
And we can see that we successfully generated our payload. Let's run ls, and we can see we have our two files right there, right? We have a juicy potato, which when run is going to allow us to run something else as system. And then we have taters.exe, which now is our payload, which we could run with juicy potato. And then hopefully, if we run taters as system and it calls back to a listener, we'll then obviously have a system level shell. So now the only thing left to do is to transfer it over to this other shell, the lower level user shell we already have on our victim system. So to transfer it over, typically most of us, what we do is we spin up an HTTP Python server, and then on the victim system, we'll use something to download it then. So there's obviously a few ways you could download it. If you have access to the GUI, you could use a browser. We don't have access to the GUI. You could also use a simple PowerShell command to download it. But I found that for some reason, I couldn't really get a stable PowerShell session going on the victim system. Then in command prompts, if we do have something like certutil or curl installed, we could obviously use that, but neither of these binaries are on the victim system. And so instead of trying more different workarounds, I just thought this is maybe an excellent opportunity for us to learn a completely different way of transferring files between, yourself and a victim system, just so you have a secondary tool in your toolbox. So this is actually incredibly simple to do because we're going to use an epic tool, an epic Python script called SMB server from the impacket framework. Now I'm here on Kali Linux, which comes pre-installed with impacket, but in case you're on some other distro, you can go ahead and just download the entire framework. I don't know if framework is the right term. It's probably more correct to say it's a collection. It's a collection of different Python scripts that have a broad range of functions and are incredibly useful. So impacket is definitely something as an attacker, as a pen tester or red teamer, something you always want close by in your toolbox. Right, so just for the sake of convenience, though strictly not necessary, I'm just going to make a copy of the SMB server Python script right in this folder. So you can see here CP, you can see the directory where we can find SMB server, the actual Python script. And if you're on Kali, you should find it in that exact same directory. That's the default directory where it would be installed. And then of course the full stop just indicates we want it copied to our current directory. Just gonna run ls, and we can see that we now have SMB server.py right here in the same folder. So I'm just gonna clear, just tidying things up. So let's go ahead and run the script, which is essentially just going to create a SMB server on our system. So I'll paste the command right there. You can see we're using sudo privileges. We're calling the Python interpreter. We're pointing it to our SMB server.py, which is obviously in the current directory. And then getgood here, friends, is just the name I'm giving to our SMB drive, but you could call it anything you wanted to. And then after that, we see potato, meaning the drive getgood, I basically want mapped onto a directory. Which directory? The potato directory. So I'll hit enter. Fill in my super secure password. So now that our SMB server is running, all we really need to do is go over to the victim shell, copy the two files over, then run juicy potato, and hopefully we have a shell. But obviously one thing is missing in that picture, which is our netcat listener. So before we forget, before we head over to the victim system, I'll hit Ctrl-Shift-T to create another new tab, and I'll run nc lvmp, and then if you remember, in the MSA Venom command, we specified port 3333, so then obviously our listener has to be on the same port. So I'll hit enter. Now let's head back to our victim shell. So now it's pretty simple, because all we need to do is basically use netuse, and then specify the drive letter we want to give this mounted SMB drive. In this case, I'm just going to use X, but as long as it's not in use, you can use anything. I'm going to specify the IP, in this case it being our IP, and then the name of the drive, which we just saw, we gave it as getgood. Obviously, if you chose a different name, you're going to have to change that. We can see the command completed successfully. So now, friends, we basically have on the system an X drive. And what is this X drive? Well, this X drive is the contents of the potato directory on our attacker system. So I think that's pretty neat. So now we need to copy the two files over to this system. And as I like to do, I'm just going to copy it over to the temp directory. So we can see that successfully copied. And then after this, I will also obviously copy our payload, which I named Tater. Oh, I didn't name it Tater, excusez-moi. I named it
Taters, precious.
Cool. Right, so we can go into CD Windows, temp, and now all we in theory need to do is run our juicy potato binary, point it to our payload. It will run that payload with system level privileges. It's going to call back, and it's going to create our shell. Simple, huh, friends? Except I'm not going to run juicy potato right now because I'm going to spoil the fun. It won't work. And here, I feel right now, this is actually the start of today's lesson, because we're encountering a problem, and as most of you know, what hacking or what pen testing or what red teaming or what cybersecurity is encountering new problems and needing to figure out new solutions. That's 90% of what you're doing. But you're going to have to trust me, it doesn't work. You can obviously go ahead and try that yourself if you'd like to, but I'm going to show you why it doesn't work. So let's just go ahead and run taters.exe directly, because obviously we should be able to run it, and then it should call back. It's not being run as a system, but it should still be able to call back to 333 and basically give us a shell, correct? So let's do that. Oh, the system cannot find the file. Okay, so maybe just we didn't copy it over properly. Perhaps that happened. So let's just repeat that quickly. Copy it again. Okay, it says it copied, so it has to work, right? So taters.exe. And now it's telling us it cannot execute the file. Strange. Let's try again. It's telling us it cannot execute it. And if we wait just a couple of seconds and run it again, now it's telling us it can't find it. And so obviously, friends, in case you didn't know what's going on, there is an incredibly high likelihood, almost certainty, is basically the signature of this payload is being picked up by an active AV or some endpoint detection, probably Microsoft Defender on the system. So first off, it's blocking it from even running. It's not allowing us to execute it. And then it goes and immediately deletes it. So it seems that this simple MSA Venom exe payload didn't work. And just to share with you kind of the process that I did, when I was practicing this box by myself and preparing this lesson, I initially just thought, well, this isn't a big deal. I went kind of with a very obvious exe choice, and I didn't do any kind of encryption or anything like that. So obviously, perhaps I can try a bat file or a bin file, or maybe even use a PS1 file or something like that. And then if I change the format, perhaps Defender won't block it then. So I went through a whole gamut of different formats, but the result was always the same. And so then I thought, well, why don't I employ some of MSA Venom's fancy built-in encoding, the Shikata Ganai or NOP, or, we could even encode it multiple times for good measure, 10 iterations, crazy encoding, brah. But alas, none of that worked either. So then I even tried to combine different formats with different encodings, but alas, no cigar. It just seemed like anything I tried to create with MSA Venom, this system immediately blocked it from running and then deleted it shortly after. And so friends, as is often the case, in the greater scheme of things, if we continuously bump our head against the wall, it's great to kind of take a moment to pause and zoom out and see if instead of trying different iterations in the current game we're playing, is there perhaps another game altogether? And of course, there almost always is, because in attacking in cybersecurity, our decisions, our options, our action branches, we can say, can exist on multiple levels. So what do I mean? I mean, now I'm on the level of different MSF Venom payloads. So I'm trying different MSF Venom payloads. Okay, but what if I stop, pause, zoom out, go above this specificity of using MSF Venom and asking myself, well, is there anything else I can run to achieve the same goal? Because what I'm not seeking to do is generate a MSF Venom payload. That's not a rule. What I'm seeking to do is to run something that can call back to a listener on our own system. And of course, there are many options beyond MSF Venom that can help us achieve that. So again, what we want is something we can execute that will call back to a listener on our system. And now that we know that they do have some form of antivirus or endpoint detection running, and that it obviously is pretty good, at least as far as we know right now, at picking up signatures of known malicious software, well then we ask ourselves, is there something we can run that's going to call back? And is there perhaps something that's legitimate that we can run that can call back? So do we know anything like that? And of course we do, because we're running an instance of it right now. Now we're running netcat as a listener, but netcat builds itself as the quote-unquote Swiss Army knife of network tools. I'm not making fun of it, netcat is literally insane. But the point here is netcat can work in both directions. Netcat can both receive, as we're using it now as a listener, but netcat can also send. It can also send out and connect to a listener. Okay, so it actually seems pretty simple. We can take a copy of netcat and we can send it over to this victim system. And instead of triggering an MSA Venom payload with Juicy Potato, why don't we just trigger netcat and call back to our listener? So this is obviously a great option. It should fill you with excitement and zeal at the prospect, but I can immediately think of one giant problem. This problem relates to the thing I put a lot of emphasis on earlier in this lesson. And what is that? Juicy Potato can spawn a new process, but it cannot execute a command. So with netcat, what's the issue? Well, netcat, we typically need to run a command line and then provide arguments, including, critically, the IP and the port. If we just copied netcat over to the system and we ran it with Juicy Potato, it'll just spawn netcat as a new process on the system, which is not what we want. Okay, so let's think about this problem then. So we want to run netcat, but maybe we can't actually run it directly with Juicy Potato. Maybe what we basically need is some exe or some executable that can act as a proxy that is basically going to, in its turn, call netcat and provide arguments at the same time. So is that something we can do? Well, I'm sure you've done this many times before in something like a bash script, right? Creating a bash script is very easy, and often what we can do is we can just consolidate different commands that we were going to type out in our command line, and we can just put them all in a bash script. So we know there is some mechanism for doing that, but that has a problem in and of itself, which is, first of all, bash is for Linux. We could do PowerShell, but it presents the exact same problem because we're going to have to invoke the interpreter and provide an argument, which is the script. So we didn't solve our problem, we just passed the buck forward. So what we really need is something like a script that can run a command, but that thing shouldn't be a script. That thing should be a self-contained executable. So are we able to do that? Of course we are. And so one simple, at least in this situation, and clean tool for this job is C. Why? Well, C has the exact library to allow us to interact directly with the Windows command line interpreter. And you may or may not know that Windows is predominantly written in C itself. So it's obviously a perfectly suited language to interact with the operating system with. But I just said we're going to create a C script, but I also said we need an executable. And in case you don't know, it's very trivial to create an executable directly from a C script because we just use a compiler, and that's exactly what a compiler will do. Compiler will create an executable form of a C script. Okay, so I just wanted to take this quick moment and share everything that kind of went on just now and my thought process of explanation of where we're going to move ahead now. So let's head back in the terminal on our Kali machine. So here back in our Kali machine, as I just discussed, the goal now is to create a script that will execute netcat on the target system while also providing arguments. But before we even get to our script, we'll obviously have to download a version of netcat that's compatible with Windows. Since we're on a Linux system right now, we couldn't just copy this version of Linux onto the Windows system. It wouldn't work because it's not compatible. They're different architectures. So the first thing we need to do is just go ahead and download a copy of a Windows version of netcat. And so the specific version of netcat that we want, or at least that I found worked, is from this page, eternallybored.org, and it's netcat 1.11. Also note, I tried different versions. I tried one from a GitHub repo, and it was actually not compatible. So you're free to try different versions, but I would recommend for the kind of smoothest experience to simply go with that. So I'm just going to click and download. I'll open that, and I will extract it right here. Right, now back in the terminal, let's just go and copy that file right here. So I'll go downloads, netcat, and the version we're looking for, friends, is actually the 64-bit version. And so I'll copy it right here, but I'm going to rename it to simply nc.exe, just for convenience sake. Great, so we have netcat, and now, of course, we've arrived at our repas du jour. That's fancy French for a meal of the day, which is going to be our C script. So I'm just going to go ahead and use Nano. You can use Vim or Vi or VS Code or whatever you want to create this. Doesn't matter. Literally doesn't matter, friends. And I'm just going to call it main.c. So I'm going to copy and paste the complete script here, and we'll go through it real quick. And so very simply, friends, right here at the top, you can just see we're basically importing a library called stdlib.h. This is just a standard C library, and you'll almost always import it in most scripts that you use. And then here, if you're used to Python, you may not know this, but we always have to have a function, a main function, in C. You can't just start writing your code. So you can see basically here we're just declaring our main function, and everything inside of these curly brackets, i.e. this entire script really, is contained within our main function. Return 0, don't worry about that. That is again just telling it if it gets to that point, we executed successfully without any errors. So that's just a way for somebody, if you're doing debugging, kind of to know if there was an error code or not. But then obviously the kind of backbone of this entire script is this single line. And system, right there, that's a built-in function. That's a built-in function from this library. Hence why we're importing this library, because we want to use the system function, the native C system function. And this function is pretty badass, because basically we can provide it an argument, and then what it's going to do is it's going to send it directly to the Windows command interpreter so that it will execute. So just as a brief aside, the system function is very powerful, and therefore it might stand to reason that more advanced forms of endpoint detection or hardening will actually disable the direct use of this function by a lower level user. In any case, we can just see that what we're going to do is we're going to execute nc.exe from the Windows temp directory, and that's just because we know we're going to copy nc.exe in the Windows temp, and we provide our IP and we provide our port. That's obviously just telling it where to connect back to, which listener, and then we're going to spawn a new instance of the command prompt in our listener. Great, so that's it. If you're in Nano like I am, you can hit Control O, you can hit Enter, and then you can hit Control and X. And if I run ls, well, we can see now we have our main.c. So we're almost there, but there's one important step left, obviously. We need to compile this main.c into an executable that we can run. We can't just copy a C script over and have the command prompt run a C script directly. That won't work. And so to do this, we'll use something called mcguyver, quite a mouthful, but an excellent and very useful and widely used tool. And as you start going from beginner to more intermediate, and you start going from not just using payloads, but creating your own, packaging your own, injecting into other things, all these kind of things, you know, the introductory level manipulation of payloads, you'll be working a lot with C or C#, and this is an excellent compiler that you'll be using to create executables. And so in any case, it doesn't actually come pre-installed with Kali, so you have to install it. I've already gone and done so, but I'll just share the command with you right here. This is that command. Obviously, you want to run sudo apt-get update first, just to make sure you're pointing to the latest repositories. But then you just run sudo apt-get or apt install mingw. I always want to say Mingy.
Minji, what you doing?
mingw-w64. So I'm not going to run it because, as I said, I already have it installed. But if you don't, please go ahead and do so. And so now the final thing is to run our command, and we see the specific version, which is the 64-bit version of min. I'm going to stop saying the name, just the compiler. And we're giving it our input file, which is main.c, right? That's the script it's going to take as input, and then O for output. And in this case, I'm just going to call it reverse.exe. And we didn't get any response, which is typically good. Let's run ls, and we can see that we have reverse.exe there. All right, that's excellent, friends. I believe we have everything we need, because right now we have our copy of netcat, which we're going to run on the victim system. But remember, we can't run it directly. What we need is some proxy that's going to invoke this very netcat and give it the required arguments. And that is, of course, what we just created with reverse.exe. And so let's just head back directly to the victim system. Great, and since we still have our SMB server running, I didn't close that, we should be able to just copy those exact files. You can see that was a success. And now for our reverse.exe, and that was a success as well. And so now, friends, all the pieces are in place, and we basically have one final thing to do, which is to run Juicy Potato. So I'm going to copy the command here, and before we run it, let's just quickly go through it. You can see here the port we're going to use, and here just be sure we have to use a port that's not currently in use by the system, and most systems don't use the lead port, so we should be good. And then here is obviously the process, P for process, that we want to spawn. And then the T asterisk, don't worry about that too much, but it basically just tells, there's basically two ways that Juicy Potato can try and run this command, and the asterisk just means try both ways. So if the first one doesn't work, try the second one. And then the final kind of important thing to actually know here is just C. And what C is CLSID. Now, I don't want to get in this too much, but it is actually an important thing to have some level of awareness of. The class identifier, CLSID, that's just a unique ID that Windows gives to every single different component, every software component, every class, every application. And Windows basically just uses that to keep track of different versions, right? I'm going to use a very simple example. If you think of something like Windows 10, right? When Windows 10 first came out, and by the time it was replaced with Windows 11, obviously there were many different updates and many different iterations of it. And oftentimes, let's say that for some reason, this is a stupid example, but it illustrates the point, there was some issue with the recycling bin, right? Let's say halfway through the life of Windows 10, the Windows team somehow changed and updated the recycling bin. Well, in a sense, though we're still in Windows 10, the version of the recycling bin has changed. And so what a CLSID is every single component on the Windows system has that, and that's just the way for Windows or Microsoft to keep track of the exact version that's currently running. Now in our specific case here, this CLSID is for the particular COM object that Juicy Potato is going to try to impersonate or interact with. Now this standard one, this is the one that came from the GitHub repo, it should work. But if it doesn't work, you can get a PowerShell script that will go ahead and enumerate the CLSID version of the COM object that you're looking to attack. But in any case, we should now be able to run this. So let's go ahead. And we have an OK there, which seems good. So control and hurrah, you can see here, right friends, that we managed to get a reverse shell. And so let's run who am I? And you can see that we are system.
Nice.
Alright friends, so I hope you'll enjoyed that walkthrough. This was honestly probably my favorite lesson that I've created to date, just because it really challenged my standard approach to things and forced me to get a little bit crafty and learn how to color outside the lines to ultimately solve the problem.
Hi, Lisa. Hi, Super Nintendo Chalmers. I'm learning.
Now I do understand what I did here was probably kind of a clunky way, and I'm sure there are way more neat ways to basically solve the problem we encountered. But I liked it, and I think it was kind of cool in the way that we could have leveraged a legitimate program and just combine it with a super simple little C script, and voila, we basically in effect get a payload. Right, and so before we say goodbye, I would like to instantiate a new tradition today in the outro. Every outro, I would like to basically share one takeaway message that I learned in this lesson. Now, I want to focus on meta lessons. I'm not really too interested in any specifics. And what I mean here specifically are what are some of the key takeaways that are transcendent truths, right? That don't depend on any specifics. Even if commands change or the details change, the underlying principle will still hold true in 2 or 5 or 10 years. And so my takeaway lesson for today is whenever you're in a situation where you can spawn a process but you would like to run a command, you can in effect do that, and that's because any command can in effect be turned into a process. Today, of course, we did that by creating a simple C script, compiling that C script into an exe file, and then when we execute that file, it spawns the process. So I'm also super interested to hear if you had any other insights or key takeaway meta lessons from this lesson to share with the rest of the community. So I'll be back shortly, and we'll actually do one more little sojourn in Jeeves, and that's simply because there is actually another path to privilege escalation via a pass the hash attack. If you want to make sure that you won't miss it, because it will obviously be awesome, please subscribe and hit the notification bell. Until then, friends,
Peace out.